Good afternoon, everyone. Thank you for joining me today in this webinar. My name is Angela Norris. I am an AEC Tech Specialist with ATG. A little bit about myself. I'm a registered architect. I have been in the industry for over 25 years. I have been with ATG since 2020. And I'm really excited to talk to you about HIVE and content management system. I'm going to do this today by creating a custom family and load it into Revit or HIVE, and then we're going to load it into a project. I'm going to be using 2023, so you're welcome to join along and follow me as I do this demonstration. Okay, files, so many files. AEC firms have files upon files. We have Revit files, we have family files, we have PDFs, we have images, just numerous amount of files. And in those files, most of the time, firms put those on their server and they're not accessible to remote employees. So what do you do with all of that information? Well, that's where HIVE comes in and allows you to have a content management system. So the agenda today, what we're going to cover is what is HIVE, general navigation, how we're going to navigate it within a Revit project environment, and I'm going to use a project example to show you how this works. So what is HIVE? HIVE is an industry-leading content management system developed specifically for the AEC industry. It is a way that firms can organize, manage, set permissions, and ensure the latest content is kept up to date and available for all project participants, even when working remotely. These users can find Revit files, Revit families, templates, schedules, AutoCAD files, PDFs, images, and other type of files so that they can quickly use them in organized libraries, tags, favorites, and anything you can imagine. Okay, so what can HIVE do? It's the leading content navigation system developed specifically for the AEC industry. It has the ability for account management, for group management, user management, content browsing. This is where your users can quickly search and find the content that they need, search and filter, tagging, save those searches, content details, and drag and drop into design models. Where can you get it? ATG offers this product software. It's available for purchase. You can download a free trial version to see the power that it has to offer with your firm. So here is a little bit about the general navigation. There is a toolbar, search content, shortcut to save searches, shortcut to libraries, and the ability to filter information to find a specific item that you're looking for. HIVE works with Revit. It's integrated and an add-on to upload component families, PDFs, anything you need. So I'm using Revit 23, and if you would like to join along in this demonstration, I'm going to get started and we're going to create a custom family, create that custom family, talk a little bit about parameters and how to load that custom family into HIVE and download it to use in your project. Okay, so we're going to create a family. I'm going to do this by creating a family type. You're going to use English Imperial. What I like to do when I start a family type is begin with the generic model. All right, the reason I like to do this is it gives me a clean slate. There's nothing here but your horizontal axis for center front, your vertical axis for center, left, right. And here I don't have anything else in here, so I can create all the parameters that I need to build a custom family. I'm going to start by building some reference planes. And it's very important when you create this reference plane to name them. You're going to come back and use them. It gives you a place for orientation. You can set the reference plane to start the extrusions or whatever type you need. This one here is going to be called right. Come over here and call this one left. And as you can see, I'm not worried about the dimensions. We will take care of that later. This one here is going to be called back. And this one here is right. Okay. Whoops. Okay. Front. Now I'm going to dimension these. I'm going to build a bookcase, and I want it to be 6 feet wide. So I'm going to start with these reference plane and dimension those. Select this. It's highlighted. Change to 3 feet. Select this one. Change to 3 feet. Dimension the width for 2 foot depth. Change this to 1. Change this to 1. Now an overall dimension. This is what we are going to use to create the parameter for our adjustability for the width and the depth for this bookcase. First constraint that you need to do, it's very important. Select your dimension, and there's an equal sign. Select that so that the reference plane moves equally in the direction within that vertical reference plane. So as you adjust this parameter, it will adjust on either side equally. I'm going to equal that one as well. So this is a piece of casework. In this piece of casework, we're going to have a couple of panels and some bookshelves, and I'm going to copy this over 3/4 of an inch. Copy this one over 3/4 of an inch. And I want to have a center one. I want this to have a center. Bookcase get large. It's going to need a support. So I'm going to go here, and I'm going to create a reference plane. And this time I'm going to offset this 3/8 of an inch here and here. Okay, let's give these panels some dimensions so that we can create parameters for those. It's going to be 3/4 of an inch. All right, a little bit about these dimensions and this dimension style. I do not like the 0 feet. I want to suppress that to clean up my fractions. You do that, default linear style, select that, edit type, scroll down here, and under unit format, select the default, uncheck user project settings, and suppress 0 feet. There we have something much cleaner that we can work with. I'm going to dimension this side. And for this center, we need to dimension this. Pull these out so you can see a little bit better. I'm going to up the scale 3/4 of an inch, a little more readable. And since this is going to also have a parameter to match the thickness, I'm going to dimension that. Just like we did here, I want to constrain that to an equal . so that it will move accordingly to this vertical plane. Okay, so now we have created in floor plan on a reference level the dimensions that we need to control the depth and the width. So let's go to the front view so we can do the same thing for height. One thing I like to do is move this reference level off to the side. This makes it a little cleaner, a little easier to read. Okay, create the height here. Again, not worried about it. I'm going to dimension this now and set it. I'm going to start here with assigning it to a bookcase. Name this top. I want to have a base, so I'm going to create another reference plane down here. Call it base. Another reference plane for the top thickness, 3/4 of an inch again. I'm going to call this bottom of top panel. All right, so let's add some dimensions for more parameters. I want to make that 4 inches. And here, 3/4 of an inch. All right, so now we've created the height and the width and depth dimensions for the controllability to create different family types. So the first thing we want to do is create a parameter that will allow for the adjustability of the bookcase that we're going to create. And to do that, select your dimension, come here to create a parameter. This pulls up your parameter properties box. Under parameter type, there are 2 different types of parameters. You have a family and you have a shared. The difference between these is this is a standard basic family type that you can create for table, a bookcase, anything that you don't need to be tagged or scheduled. A shared parameter is one that you can tag and will appear in schedules. For this bookcase, we're going to keep it simple and make it a family parameter. Here we have 2 different types between type and instance. And the difference between these is this type allows you to create multiple types of the same family. And this one is instance, where your bookcase would just change on an instant parameter, but there would not be different types. So we're going to call this one width. And as you notice that this discipline is grayed out, type of parameter is length, it's grayed out, and it's going to automatically group it under dimensions because it was the dimension that was selected. Okay, we're going to do this again for the depth, and then again for thickness. Now you can select these together, and from your drop down, you've already created it. So now our thickness is set. So we are ready to go from the reference plan with our width, depth, and thickness created. So I'm going to go to the front view and create these parameters to adjust the height. Just like we did before, we're going to come in here. Create a height. This one, we're going to create one more additional parameter, call it base, height. And this one, we've already created the thickness, so we want to assign it the same parameter. Okay, before we go any further, I'm going to save this. It's a bookcase example. Before we go any further, let's test this. Let's make sure everything's working correctly. So in your type, and let me show you something that's really cool in 2023. All right, when we pull up, this is your family types that pulls up the types of families that you can create with the base, depth, height, thickness, and width. These were the parameters we just created. So if you select height, it automatically highlights it so you can find your way. Thickness, highlight it. This is very helpful if you have a user and multiple parameters set up and they don't know where that parameter is. They can click on it and find it within the custom family. So for our height, I'm going to change this to 3 feet and it's adjusted correctly. I'm going to change that back to 6. Go back to the reference view, change the depth to 1. We're going to change the width to 8. And all those are working just fine. Everything equal has stayed the same. We're good to go. We're ready to start creating the extrusion for this custom family. And we're going to load in HIVE and load it into a project. I want to go back and make my width 6 feet again. I'm going to keep it the way it was and my depth 2. Okay, let's start with building some extrusion for these side panels. Create, on your Create tab, select Extrusion. I'm going to check our reference plane. It automatically sets it to the reference level, which would be your finished floor. Okay, now let's create a left panel. One important thing to do is to always lock these in. That way they are constrained with the reference plane and the parameters that you've created and will move correctly. Lock those in, lock it in, and create this, and lock these in as well. Let's make sure all those got locked in. Make sure I didn't miss one. Okay, I think we're good. Okay, so now we want to assign this extrusion height. Revit automatically defaults for your first extrusion to 1 foot. Well, we know that this bookcase is going to be 6 feet. Instead of typing in 6 feet, going back to your front view and aligning it with the reference plane for type, there is this button here, Associate Family Parameter, that you can select, and you can select height, say OK, finish edit mode, and there is your extrusion for your panels. If you go to the front view, you can see that those have automatically already been set to height. So if we go in here and change this height to 3 feet, we didn't have to align anything. It's already associated with that parameter. All right, let's build the top and the base. So back at our reference level, let's start with the base, create another extrusion, check my reference plane, it's on the right level. Around here, just constrain all these down, make sure that they're with the reference plane correctly. I'm going to come back over here. I'm going to select that Associate Family Parameter. This time it's going to be base height. Finish edit. Now I'm going to go to the front view. It's set associated to the right parameter. Got a bottom type panel. So this one, I'm going to associate this to that reference plane. Back to your reference level. Create another extrusion. This time, set the reference plane to bottom of top panel. pull this, constrain it down. Now this defaulted back to the dimension of the base height because that was the last one I used. This time, since I've associated it with the reference plane, I do want to align that with the top. So I'm going to change this to 3/4 of an inch. Finish edit, go to the front view. And now I want to align that with the top and lock it in. Check this again. And go to 8. Everything moves correctly. Okay, now there are parameters that you can create that are not dimensionally related under the family types box. It brings up family types. And in this box, it shows you under dimensions all of the dimensional parametric relationships that we want to control for height, width, depth. So here is a way to create a new parameter. And I'm going to create a book case finish. Now, these are not grayed out. You have the adjustability to set these for common, length, or dimension. Since this is going to be a finished material, I want to change this to material. Now, there are many different ones that you can choose dependent upon what type of parameter you want to set. It's going to be material. It automatically defaults to a group parameter under materials and finishes. Say okay, defaulted to this category, and you can change the finish. Okay, one more thing I want to do for this bookcase. We need shelves. And I want to create some shelves, but I want those to be equally distributed so when I change the height, the shelves change accordingly. The way you do that is create a formula. Back into my family types box, I'm going to create a new parameter. I'm going to name this one shelf height. I'm going to leave it at common, length, and dimension to fall in that category here. This is where you create the formula. So the formula I want to create is I want 3 shelves. So I need to divide the height by 4. In the formula box, I want to type in height. This is very important that this matches the parameter you want to use in the formula. So type in the parameter, height, space, the division symbol, space, and 4. And when you do that, since we have a 6 feet tall bookcase, it automatically calculated what the height of those shelves are going to be when they're divided by 4 for 3 shelves. Okay, so now we need to create the shelves. I'm going to select the top reference plane, and I'm going to copy it down 1'6", 1'6" again, and 1'6" one more time. To associate these levels with the parameter that was created for the shelf height, I'm going to dimension these shelves. Pull it out here. Select it, and under the parameter that I just chose or just created, I'm going to change that to shelf height. I'm going to change this to a 3/4 inch scale so these parameters are a little easier to read. Pull this off to the side, pull this off to the side, and pull this one down too. Okay. All right, before I draw the extrusions for the shelves, I'm going to check this to make sure it is going to adjust correctly. my formula. You can see that it changed the shelf height, and there we go. We have 3 equal shelves. Now to draw the shelves. Create another extrusion. This time, I want to set the plane at the front. Okay. So creating the shelves, I'm going to lock it into the reference plane. Lock it in. And I want these to be 3/4 of an inch. So I'm going to offset this 3/8. This side and this side. Trim this up. Select your shelf. I'm going to copy this down each reference plane here and here. We need to set some constraints so that they will move and adjust accordingly about the center line of the reference plane for our formula. We need to dimension these like we did before to the center line here and here. Constrain it to the equal. Drag these over so we can read them a little bit better. Here again, the second shelf. Constrain it to equal. Very important to constrain these so that they move correctly as you adjust the dimensions for your family type. Whoops. This needs to be associated with that reference plane. Let's edit that, get it to the bottom, constrain it equally, pull this over, you can read it. All right. We need to associate the thickness parameter so it adjusts to the same thickness of our side and top panels. You can do those parameters also within the extrusion that you're creating. They don't have to be here outside. So just like we did before, I'm going to dimension it here. Select all 3 dimensions, apply thickness. Finish edit mode. I'm going to show you something about these associate parameter for changing your height. And I want to check this real quick, just one more time, make sure that these change to 8 feet. So it works. We're in good shape. Okay. So if you go to your 3-dimensional view, what you see here is that these bookshelves defaulted to the last top panel that we created at 3/4 of an inch. Well, that's not what I wanted. I want it to associate with the depth of the bookcase. So we can go to the associate family parameter, change it to depth, say okay, automatically associate it. So that's a way, instead of aligning to the reference plane, quick and easy way to associate it with that parameter. I'm going to clean this up, join my geometry. We have our bookcase. I like to check it one more time. OCD, I'm going to make sure everything works. I'm going to make it 1 foot. I'm going to make this 6 feet. I'm going to change my thickness to 2 inches. I want to change my base height to 2 inches to match the panel. Everything looks good. Okay, so that might need to be So we had, see what happens? Didn't constrain it. So I came up with the error message where it didn't look correct. So that's the point of making sure these are constrained. So I'm going to go back to my reference view and let's make sure that this works. Reason why it's great to check these to make sure that it works right. Let's make sure. There we go. Problem solved. That constraint is extremely important. All right, save this. Now, one thing we want to do before we import it into Hive and put it in our project, we created this in a generic family. All right, so we want to go here to family category and parameters, select this where it's a generic model because we really don't want a generic model in our project. Scroll up here, assign it to casework, select OK, and now it is a casework family type. Save it again. All right, let's close out of this and let's load it to Hive and let's put it in a project. I'm going to open up a project. Going to go to a floor plan view. And I'm going to load this and put it in the project. Now, normally most people without Hive, they would select the component, they would load the family, the family would pull up from the out of the box library where you can select the different types of families that you want to put in. And that's really all you're limited to if you're putting in a component. So with Hive, you can select any type of component, PDF. If you wanted to put an image, it's all stored within that component management system. To load those, go to CTC software. This is your Hive icon. It is a Revit add-in. And this select it. Takes a second for it to load. Okay. Here is your Hive opening box. Here are the toolbars that we talked about. These are your different categories that you can store your content, and this is your search bar. One you're going to use the most is going to be libraries. And here is the organizational structure for those libraries. So you can set this up for your architectural, MEP, assemblies, electrical, any type of information that you want to store. And it has a large storage capacity. One of my favorite things that Hive can do is this reference material library. If I go into this library, I have PDFs of anything that I need to do to reference back to as I'm designing a project. Graphic standards, construction drawings, I can put in building codes, ADAG for my ADA accessibility. It's endless. As many PDFs as you want. This is a great library for your users to have immediate access to the PDFs that they're going to refer back to as they're developing their design. So let's load our bookcase into the live Hive library to put in our project. And doing that, we want to add content, select the library that we want to put this in. We're going to put it in the demo, and then we're going to add the file. Here's the bookcase we just created. I'm going to open it. It's going to take it a second to load. When it loads, you'll see it here, process. You can tell by this that it was successfully loaded. Okay. Now that it's loaded, you go back to home. open up the folder that we put it in our search bar, we want to search for that bookcase. Here it is. This is the one that we just loaded into HIVE. Select it, load it, give it a second. It's going to put it in the project. There's our bookcase. Go to View, and there it is. From here, actually just like a casework, family, we can edit it here, can make the height 4 feet, can make the width 8 feet, check the adjustability, everything works just like we intended it to do. Okay, so in conclusion, HIVE allows searching all content in independent folders. You can search for specific attributes within the content, include custom tags and categories. This content can be hosted in the cloud or exclusively on the local network, and your users are allowed the ability to instantly have the consumption of files to drop them into the project, and not just Revit families, but as well as PDFs, images, anything that your users are going to need to produce the construction drawings. So does anyone have any questions? Tanya said she is recording this to take notes. That's great. Thank you. Okay, if there's no other questions, thank you and have a good day.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.